This is Mr. Precella, and today we're discussing consumer loans in Math 1332. Hopefully you've had a chance to read through your book about consumer loans and to watch the Pearson video. And I'm going to work some homework examples right now. So let's see. Problem number 1. Compute the monthly payment for an add-on interest loan of $990 with an annual interest rate of 7% for a term of 3 years. Well, hopefully you read about add-on loans in your book. An add-on interest loan, they just calculate all the interest up front, add it to the 990, and then divide. In this case, 3 years, monthly payments. How many payments would there be altogether? 36. So with the add-on interest, we're going to calculate the interest using I equals PRT. So that would be 990 times the interest rate is 7%. And the time is 3 years. I equals PRT always uses 990. I equals PRT always assumes T is years. So punching 990 times 0.07 times 3 into my calculator, I get $207.90. So that's the amount of interest. You're going to add that to the 990 and divide by 36. Why 36? Well, monthly payments, if it's a 3-year loan, 3 times 12, 36 payments altogether. So I'm adding the 990. So I have 1197.9 divide by 36, and we'll round this to dollars and cents. $33.28. Okay. $33.28. This is not typically the way you would calculate a payment if it were, say, a house payment or some huge purchase, okay? But add-on interest loans do exist. Let's see. Here's another one. Problem number 2. Compute the monthly payments for, it's very similar, right? For an add-on interest loan of $900 with an annual interest rate of 12% and a term of 4 years. I equals P times R, 12%, 0.12, times 4. So let me clear this. Move this over, put my calculator right up here. 900 times 0.12 times 4. That's an interest of $432. So they're going to add that to the 900 and divide by what? If this is a 4-year loan, how many months are in 4 years? Is it 48? Yeah, 48. So let's add 900 plus 432. That's going to give us a 1332. See, plus 900, 1332. Divide by 48. So $27.75. Okay. Problem number 3. sort of flying through these. Let's see, what's number 3 say? Angela's bank gave her a 5-year add-on interest loan for $6,010 to pay for new equipment for her antiques restoration business. The annual interest rate is 9.56%. How much interest will she pay? And what are her monthly payments? Oh, so this one has, we've been doing that when we're answering these problems up here. We calculate the interest and then we figure out the monthly payments. But on these it was only asking for the monthly payment. So this is the exact same thing. Let's calculate the interest. I equals P times R, that 9.56% we'll write as 0.0956. P times R times T, it's a 5-year. So let's punch in $6,010 times 0.0956 times 5. So the interest they're charging her, $2,872.78. So that would be this first answer right here. I'll circle it because it goes in that box. That's the amount of interest. Now let's calculate her monthly payment. Well, she's going to have to pay back the $6,010 plus this interest. So let's add those together. And this is a 5-year loan. So we're going to divide this by what? How many months are in 5 years? Well, 12 months per year times 5 years. 12 times 5, 60. So I'll add the 6,010. That's giving us $8,882.78, and then divide by 60. $148 and what would y'all call that? 5 cents? Is that how y'all would round it? Because that's how you'd round it. Okay. $148.05. How are we doing on time? Okay, I have time to do one more problem. Problem number 4. Now this one's a pretty lengthy one. And it's going to illustrate that there's really no way to do these financial math problems without knowing a little algebra. A little algebra is going to come into play on part C. I have a friend who teaches over at the area university that's an economist, and he's always saying, you know, you've got to be able to do some algebra to work with economics. We've sure seen that with consumer price index and inflation and so forth. But okay, so here we go with problem number 4. Anna is buying 100,000. No, I'm making Anna richer than she is. I'm sorry. Anna is buying $10,000 worth of rare coins as an investment. The dealer is charging her an annual interest rate of 8.4% and is using the add-on method to compute her monthly payments. If Anna pays off the coins in 60 months, what are her monthly payments? So it's another 5-year loan. Okay. So this part A is exactly like what we were doing in the previous problems. Calculate the amount of interest and then calculate the payment. So what we want is that payment. So the interest, 10,000 times 0.084. Now be careful, I'm not going to write 60 here. When using I equals PRT, you've got to always have T set as 5, so 60 divided by, you have to always have T in years. 60 divided by 12 would be 5 years. So let's get this amount of interest. Oh, let me clear that. 10,000 times 0.084 times 5. So $4,200. That's the amount of interest. But that's not the answer to the question. The question is asking for the monthly payment. So to calculate that monthly payment, you're going to go 10,000 plus 4,200 divided by what? How many payments are there? Well, 60 months. So add 10,000, which I could do in my head, but which all of us could do in our head, but I wanted that 14,200 showing there in my calculator. Now divide by 60. So her monthly payment will be $236.67. So her monthly payment, $236.67. Now, problem number, or the next one, part B. So we're now reading part B. If Anna makes a down payment of $3,000, how much will this reduce her monthly payments? Okay. So we want to know, what are we going to have to do here? Well, we know what her monthly payment will be if she doesn't make a down payment. So let's calculate her new down payment, or her new payment, and then we'll subtract and see how much of these going down by. Okay. So if she makes a down payment of, let's see, $3,000. So if she makes a down payment of $3,000, how much will this reduce her monthly payment? So if she makes a payment of $3,000 down, then that means that she's only getting a loan for $7,000. So 7,000 times 0.084 times 60. Let's see, 7 times 0.084. Oh, I did something wrong. That times 60, it should be 60 over 12. This should be a 5. So times 5, I'll say. So instead of $4,200, her interest is $2,940. You see, when she was, when she didn't make a down payment, when she was charging the whole $10,000, getting a loan for $10,000, her monthly payment was $236.67. Now let's see, what about once she actually pays down $3,000? Okay, then she gets $7,000 is how much she's charging. So her interest there is $2,940. So now let's calculate the payment for that. It would be 7,000 plus 2,940, all divided by 60. So That's what 9940 divided by 60, $165.67. Okay. So that's going to be her new monthly payment. Okay. Actually, you see, notice in part B it says if she makes a down payment of $3,000, how much will this reduce her monthly payment? But that's not what they want you to type in. Okay? What they want you to type in is her monthly payment will go down to $165.67. If you actually wanted to answer this question, how much will this reduce her monthly payment, you would subtract the two. Okay? But here, so without the down payment, then with the down payment of $3,000, she's only charging $7,000. So her new monthly payment, now part C. Oh, I think I'll pick up with this problem. No, actually, I think we have time. I can get it done in just a few minutes. Part C, it says, if she wants to have monthly payments of $200, how large should her down payment be? If she wants a down payment of $200. Well, if we look at how we've been calculating these things, we need to know what this, let's calculate what the amount of loan would be. A payment, to calculate the payments, you take the amount of the loan, P, plus the amount of interest, PRT, and divide that by 60. We want her monthly payment to be $200. This is the problem I said there's a little bit of algebra on here. So, if we replace R with 0.084 and T with 5 years, I'm doing the P times R times T, that's the interest, plus the principal, the amount of the loan to begin with, multiply 0.084, I know we're running out of time, multiply 0.084 times 5, 0.084 times 5, that's a 0.42, 0.42. So we have P plus, let's write this as 0.42P all divided by 60 equals 200. Ooh, we're running out of room. This is the one that takes a little bit of algebra. Now, the way I'm going to solve this algebraically is I'm going to add 1P plus 0.42P. If I combine those, I would get 1.42P. And I'm also going to multiply both sides of this equation by 60 to get rid of the fraction. So we have 1.42P equals, that's a 12 with 3 zeros. The 200 times 12. What we're doing is calculating what amount does she need to, if she only wants a payment of $200, how much should she get the loan for? What should that principal be? Algebraically divide both sides by 1.42 here. I'm having to do this quickly. So we have 12,000 divided by 1.42 $84.50, and what is that saying, 70 cents? Now, that's the amount that she should get the loan for. That's not the answer to the question. The question is, how much should her down payment be? Well, if this is going to be the amount that she needs to get the loan for, the down payment would need to be $10,000 minus that $84.50.70. 10,000 minus 84.50.70. So she needs to make a down payment of $1,549.30 in order to have a payment of just $200. This is a very nice financial mathematics here, and a very sensible problem. How much should the down payment be in order to have a monthly payment of $200? Okay, very sensible problem. And we'll continue discussing problems like this, but we're out of time right now. So we'll continue working with our consumer loans. We're even going to look at how credit cards calculate the interest. Okay? But not today, not in this lecture. It'll be the next one. It's still all here in this same assignment. So I will see you, or I'll talk to you the next time. And we're out of time right now. So bye-bye, and thanks for watching.